In 1972, a French laboratory found uranium that was missing something, and the missing part had been burned 2 billion years ago. It began at Pierre-Latte in southern France in May with a routine measurement that nobody expected to matter to anyone at all. Every uranium sample on Earth carries the same fingerprint: 0.7202% uranium-235. Everywhere. Always. This sample from Gabon read 0.7171%. A tiny shortfall, but in that laboratory it was impossible. Missing uranium-235 means only one thing to a nuclear physicist. Someone, or something, had already burned part of the fuel. The ore had come from Oklo, an open-pit uranium mine in the rainforest of Gabon in west-central Africa. Continuines of his al as Westinsa racistes. Physicist Francis Perrin led the investigation. Some samples were far worse, uranium-235 falling as low as 0.44%. On the 25th of September, 1972, France announced the answer. That ore had already run as a nuclear reactor. Not a mine that supplied a reactor. The rock itself had been the reactor, roughly 2 billion years before anyone existed. Enrico Fermi built the first man-made reactor in 1942 under a Chicago stadium. Nature had beaten him by 2 billion years. Here is why it could happen then, and can never happen now. Uranium-235 is slowly disappearing from this planet. It decays with a half-life near 704 million years. Uranium-238 lasts roughly 4.5 billion. So run the clock backwards. 2 billion years ago, natural uranium was about 3% uranium-235, not 0.7. 3% is almost exactly the enrichment we manufacture today for commercial power reactors. Back then, the ground came pre-enriched by time. But rich ore alone is not a reactor. You still need something to slow the neutrons down, or nothing happens at all. That something was ordinary groundwater, soaking into the ore body and acting as a moderator, exactly as water does in reactors today. And the ore existed only because Earth's atmosphere had recently filled with oxygen, which dissolved uranium and let water concentrate it here. Now here is the strange part. The Oklo reactor did not switch on and burn steadily. It pulsed, almost like breathing. Fission heated the water. The water boiled away. Without a moderator, the chain reaction stopped, and the hot rock began to cool. Then groundwater seeped back in, and it started again. Scientists recovered that rhythm from xenon gas trapped inside tiny mineral grains. The cycle read about 30 minutes running, then roughly 2.5 hours cooling, repeating for hundreds of thousands of years. That work was done by Alex Meshik and colleagues at Washington University in St. Louis, reading a 2 billion-year-old timetable. Its power was modest, averaging around 100 kilowatts of heat, enough, as one physicist put it, to run a few dozen toasters. But across that immense span, it released about 15,000 megawatt-years of energy, consuming roughly 5 tons of uranium-235. And Oklo was not one reactor. At least 16 separate reactor zones have been found across 3 deposits: Oklo, Okolobondo, and Bangombe. A chemist named Paul Kuroda had predicted all of this in 1956, 16 years before anyone dug up the proof. There is one more reason this matters, and it has nothing to do with the past. It is about our nuclear waste. Oklo bred plutonium and fierce fission products, then simply held them. The plutonium moved less than 10 feet in 2 billion years. No engineering, no steel, no concrete. Just wet African rock quietly containing radioactive waste for longer than complex life has existed. So, what else is buried under our feet, quietly keeping it secret? Tell me in the comments. The world is full of secrets. Go find one.